Hey class, this is Mr. Roberts, and we're going to be looking at the second homework assignment in chapter, what are we in, chapter 2? This one starts at question 18, and I think the last one is 22. So let's start with 18. It says, calculate the slope of a line graphed at right. I don't know why they didn't put ED. Calculate the slope of line, graph at right. Oh, maybe if there was a period, I guess. I think it should be graphed it right. So anyways, there's a graph here, and the question is, what's the slope of this line? One thing that I really suggest is when you see these, right, when you see dots like this, I am indicating to you that you can safely assume that those points are known, right? So when you look at these, each one of these little marks is worth 1. So you can see that I'm at 1, 2, 3, 4, 5, 6, 7, 0. So I have a point that lives, oh, hello. I have a point that lives at 7, comma 0. And I have another point that lives at 6, 4, right? 6, comma 4. So these points are known. And I really recommend using those known points to figure out the slope. So if I look at this, I can see my y value is changing and my x values are changing. My y values are changing by 2. No, they're not. They're changing by more than that. It's 2 of these major lines, but if you look at it, this is 1, 2, 3, 4. Y values changed by 4, and the x values changed by what? X changed by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. They changed by 12. So that's a change of 12. And we know that the slope ratio is the change in y, right? The delta y divided by the change in x. So you can see we've got a change of y of 4 units, change in x in 12. So that does, it can be reduced, right? That's the same as 2/6, and it's also the same thing as 1/3. So the slope is 1/3. Another thing we can see here, and it's kind of nice to note, is that we could look at a smaller slope triangle. Again, the problem with this is that these aren't known points for sure, but if you look at this change in y and this change in y, you can see we've got a change in y there that is like, well, actually that's this one, right? That was up 2/6. And then there's another smaller one that's up 1/3. Also, there's this very large one. If you look at this, if I was to start right here, I could go all the way up to this change in y, and I could run this change in x. This change in y, I think every single one of these is worth 2. So that's 1, 2, 3, 4, 5, 6, 7, 8. So that's 8 units. My change in y is 8 units, and my change in x is running from, what is that, -12 to +12, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Yeah, so this is a change of 24. And if I take 8 and divide by 24, I can see that can be reduced to, well, divide both of them by 2, and it's right there. Right, so these are all comparable ratios. They're the same ratio, right? 8/24, 4/12, 2/6, 1/3. So the slope of that line is any of those ratios, right? The reduced ratio is 1/3. For every time y increases by 1, x moves to the right 3 units. So that's the first question. Probably spent more time than I need to, right? But there's a bigger idea that I want to kind of talk about. Let's see. Which equation below has no solution? Explain how you know. Okay. Well, I think the solution that has, the equation that has no solution is B. And I think I know this because when I look at this, I can see that I have a term of -8x on one side of the equation, right? And on the other side, there's a term of -5x. So there's a -5x term on each side. And if I was to add 5x to each side, this equation would become 9 plus 2 equals 4, which is utter nonsense, right? 13 is not the same thing as 4. So it does not matter what value of x I pick. it's just never going to be case that 13 is the same thing as 4. So I know that this doesn't have a solution because my terms with variables cancel each other out. Now in the other equation here, if I do distribute the 4 here, this becomes 4x plus 4, and the other side is 2x plus 4. So this one, clearly, if I take away 2x from both sides, 2x plus 4 is equal to 4. Take away 4 from both sides, 2x is 0. And if I divide both sides by x, or by 2 rather, I do get that x is 0 divided by 2, which is 0. So x is 0 here. When I plug in 0 for x, it makes both sides of that equation 4. So this one does have a solution. So I guess the thing is how to, it says explain how you know. I would say that if your variable term cancels on both sides and you're left with a contradiction, there's no solution. So I did type that up, and I think it's important that you see that I went through the trouble of typing this response, because this really is what this question's asking, right? It's more than just, hey, which one doesn't have a solution, right? And you could do both and see, oh, one's got a solution of 0, x is 0, and the other one is a contradiction, 13 is 4. But the important thing is that you be able to state if your variable term or terms cancels, if your variable term cancels from both sides and you're left with a contradiction, then your equation has no solution. So let's move on to question 20. Question 20 says, evaluate the expressions below for the given values. So for this first one, we're given a value of x that's -2 and a value for y that's -5. So when I'm doing this substitution in here, I'd like to go ahead and write 1 minus 2, and then I'm going to put in a -2 for the x, plus 3, and then for the y I'm going to place a -5. So I just kind of do that so I can see this actual substitution happen and maybe think about a little bit more about what precisely is going on. And then if I take this another step, the -2 times -2 is 4, so this becomes 1 plus 4. And then I've got plus 3 times -5, which would be minus 15. So we're looking at 5 minus 15, which is -10. So when I plug in x is -2 and y is -5, this becomes the number -10. Let's move over to B. For B, it says plug in a -1 to this top expression here. So I've got 5 minus, open parens, and then I'm going to go ahead and put inside some parentheses a -1 minus 2, close parentheses, and then this thing gets squared. So inside the parentheses, when I evaluate that, that's a -1 and a -2, which is -3. So I've got 5 minus -3 gets squared. Now when I square -3, right, that becomes +9. So -3 times -3 is +9. So this is now 5 minus this +9, and 5 minus +9 is -4. So the answer there should be -4 for part B. Let's go down to C. So C says place -1 into this. So my numerator is a -5. My denominator now is -1 plus 1. If I simplify that, I've got -5 divided by 0. Uh-oh, right? Division by 0 is undefined. So this is, I guess I'll just write this is undefined. D-F-I-N-E-D. So it's definitely not 0, and it's not -5, right? Anything divided by 0 is not defined. Let's move on to D. In part D, we've got x is 2, and playing the role of y will be 5. So I'm going to have 1/2 times the number 2. And I'm going to write the number 2 as 2 over 1, right? So this is my value of x that I'm placing in. And then I'm going to add plus 1/3 times, and then I'm going to write, instead of just 5, I'm going to write 5 over 1. So this is my value of y. So 1/2 times 2 is 2 over 2, or just 1. So this is 1 plus, and then this is 5/3. 5/3. Now, if I want to combine these two, right, I need my denominators to be the same. So I can rewrite the number 1 as 3/3. So I've got 3/3 plus 5/3, which is 8/3. And honestly, oh, not 8/2, 8/3. Honestly, this is the perfect answer right here, right? There's no common ones, nothing to divide out. So I would say go with 8/3. Of course, 3 does go in there twice, and there's a remainder of 2. So you could write 2 and 2/3, but I really dislike this notation, because more precise, it's really 2 plus 2/3, right? But we just write 2 2/3, but it is 2 and 2/3 more. 2 plus 2/3. But really, this is the way to go, right? This is just improper fractions, fractions that haven't been reduced. Oh no, that has been fully reduced, but it's improper because the numerator is larger. But I still like it because I can see exactly what's the numerator and what's the denominator. Anyways, let's move on. That was question 20. Let's go down to question 21. Question 21 says calculate the output for the function with the given input. If there's no possible output for the given function, explain why or why not. Well, we're playing the same game here, right? So you can see this. If I rewrite this thing inside, it's going to equal x, which is, well, I'll write it. It's x over x minus 1. And we're given a value that x is 1. So if I do my substitution, and I've got 1 over 1 minus 1, which is what? It is 1 over 0. And this function has no output. O-U-T-P-U-T, because division by 0 is undefined. Done. All right, let's move on to question 22. There we go. 22. It says, oh, look at this. Look at this. We're going to do some fraction work here, right? And we're going to do it with no calculator, because clearly I ask a question like this, is like, I want to see, can you process this, right, without a calculator, right? It really is kind of the point. And to just grab a calculator and have it tell you these answers, well, it might be nice to check it that way, but it's not a great way to see what's really going on. So I think the first thing I'm then going to do is I want to change these into improper fractions. I think they're better for working. So if I've got 8 and 2/5, that's the same as 5 times 8, 40, plus 2, 40, no, 5 times 8. 5 times 8 is 40, plus 2 is 42. So I've got 42/5. And then I've got 3 times 4, which is 12. 12 plus 1 is divided by, that's 12, 13/4. 13/4. So if I want to do division by 13/4, right, a shortcut is I can multiply by 4/3. So I'm going to change this into 42/5. 42/5, and I'm going to take that and I'm going to multiply it by 4/13. And I don't see any common factors here, right? There's really nothing that I can work with. And I mean, just to kind of double check, I'm gonna break down this number 42. 42 is 6 times 7, and 6 is 2 times 3, so I've got a 2 times a 3, which is 6 times 7, and then I've got this 4, right, that I'm multiplying it by right here, so I'm going to go times 2 times 2, and then the denominator, I've just got a 5 and a 13. So this is prime factored form, right? Both the numerator and denominator are written in terms of their prime factors. So the numerator's got a 2 and then another 2, 2. So it's 2, 2, 2, 3, 7. And the denominator's got a 5 and a 13. Well, there are no common factors there, right? There's nothing, no giant ones that I could make. So I could either go ahead and leave it like this, or I could go ahead and multiply this out. So this numerator is 168 and the denominator is 65. And I am positive that there's no common factors there, right? Because I've got 2, 2, 2, 3, 7 in the numerator and a 5 and a 13 in the denominator. So this is really the perfect answer for that problem, just 168 over 65. Let's take a look at part B. So we're going to multiply these two fractions. I can see one of them's negative, so my product will be negative. And I'm going to go ahead and do the same thing and write them as improper fractions. So 5 1/2, I'm going to call 11 halves, which is 5 times 2 is 10 plus 1 is 11 halves. And then I'm going to be multiplying that by negative. 6 times 4 is 24, 25, 26, 27. So that's going to be times negative 27 fourths, right? 6 times 4 is 24, 25, 26, 27. Yeah, 27 fourths. So I know my product's negative, but I don't think I have any common factors here, right? I mean, the number 27 is 3 times 3 times 3. 3 times 3 is 9. Times 9 times 3 is 27. So I could write it as 11 and then 3, 3, 3. I do have to remember that I have this negative, and it doesn't matter where it lives, but there is this negative one factor. So my answer is going to be negative at the end. And that denominator, I've got 2 and then 2, 2. So 2, 2, 2. So you can see absolutely no common factors. I've got 11, 3, 3, 3 over 2, 2, 2. So because there's no common factors, I could just take the 27 times 11 and get that is 297, and I'll make it negative, over 222, which is 8. So I've got 297 over 8. And honestly, this is the world's most perfect answer. But if you have to, you can write it as 37 1/8. But 297 over 8 is beautiful. There are no common factors there, and I know that for sure because I looked at the factored form completely, right? There's just no giant ones. All right, now let's do a little subtraction problem. Maybe this will be better. I've been kind of disappointed I haven't been able to clean these up much, but I am going to go ahead and rewrite these as improper fractions. So 3 times 8 is 24. 24 plus 5 should be 29. So I've got negative 29 eighths minus, let's see, 1 times 2 is 2. That's 3 halves minus 3 halves. Now, if I want to do this subtraction problem, right, my denominators have to be the same. So here's this idea where sometimes you can introduce a giant one, right, to make something happen that you want to have happen. So I'm going to introduce the giant one in the form of 4 over 4. What I'm doing is I'm taking this negative 3 halves and I'm multiplying it by the number 1, and it changes how this problem looks. Right now this is going to look like negative 29 eighths minus 12 over 8. And what's beautiful about that is now I can combine those two, right, because they're like terms. So if I take the negative 29 eighths and subtract 12 eighths, it's going to be a negative number, and I literally am going to walk over here. I'm going to go 29 and 12, 9, 10, 11, carry the 1, looks like 41. So I've got negative 41 over 8, and I think 41's prime. So I have to say I'm not entirely sure, but I'm pretty sure there's no common factor. 41's prime. I can't think of anything I can divide that by. Yeah, I'm pretty sure it's prime. So negative 41 eighths is where I'm going to leave that. By the way, you could throw that in a calculator if you're having the same conundrum I am. Like, dude, is that actually prime 41? You could throw it in, and if it was, our TI-84s would definitely reduce that fraction, but I'm pretty sure it's not. So my preferred answer would be negative 41 over 8. If you have to, you could translate that to negative 5 1/8. And then our last question, D, is a -7, and we have to add to that 2/3. So what I'm going to do with this, I'm going to write the -7 over 1, and I know that I'm going to have to multiply that by something so that I can add these two fractions. And what I'm going to do is I'm going to multiply by the number 1. Why? Because I can't change -7. I want -7 to stay -7, right? It's going to be -7. But when I multiply it by the number 1, 3 over 3, this becomes -21 over 3. And what is that, you say? You say, hey, -21 over 3, what are you? And it says, well, I'm just the number -7. And it is just the number -7, right? So what I've done is I've transformed how the number -7 looks, right? I made it look like a fraction, and then I turned it into thirds. But it's still just -7. It's always been -7. But now I can add 2/3 to it. Oh, that's convenient. And when I add the 2/3 to it, it's a -21. And I add 2, I get it goes down to -19, or I should say it's going up to -19 because it was down at -21 and I increased it by 2. So now it's at -19 and my denominator is still 3. So this is perfect answer. 19 is prime, so I've got -19 thirds, and that would be the answer for that problem. And that, it turns out, is the very last problem. Thank you.